Here's some hints for some of the tougher problems on WebAssign 27B. One of the main things you want to do is work on sketching out what's happening. And so in this one we're told they put a stone on a spring that compressed it a certain distance, and the first thing you want to do is figure out the spring constant. So what did it look like before the stone was there? Well, there was this spring minding its own business, and then somebody put a rock on it, and that's obviously going to compress it some distance x. And they tell you that, and you know the force involved, that would be the weight of the stone, and using Hooke's law you should be able to figure out the spring constant. Then what happens, they push the stone down further. Here it's at rest. And so that's going to compress the spring even more. And then they're going to let go and launch it. And so now the spring is going to go back to its original length, and the stone is going to rise to some maximum height where the velocity is 0. And so if you have a picture like this, it's kind of clear what's happening. I would say the height is 0 here. They want to know how high it goes from the release point. And so that would be how high above this point from where it was released. And so what kind of energy do you have here? No kinetic, no gravitational potential if we set the height equal to 0. And so it's a big hint there. And then we let go and the spring goes back, so no elastic potential, no kinetic. What kind of energy do I have here? What is the height? So again, and you can certainly draw better pictures than this. Do your own. See if you can sketch out these situations. Number 6, we want to figure out the total distance this block slides down this ramp, and we are told how much it compresses the spring. And so this is the initial situation. The final situation, the spring is more compressed, and the 12 kilogram block is sitting here at rest. And we want to figure out the total distance it went. And so if you say this is the initial height, then you start out with what kind of energy? No elastic potential. It's released from rest, no kinetic. What kind do you have? And then it falls down. We get some kinetic, but then it hits the spring, and here it comes to a stop. So there's no kinetic. It lost the potential. What kind do I have? Can you figure out distance d? Then they want to know how fast it was going when it hit the spring. So let's erase this. It's a totally different problem, really. And so how fast was it going right when it hit the spring? And so now the initial height is this. And so you're going to take the answer from A, distance d, and now you only want to figure out what this distance is. So don't confuse that with your answer from A. And so conservation of energy, again, give that a try. And this is Atwood machine. I did put a long movie about how to do problems like this on my website, but let's just take a look. They want you to figure out the change in kinetic energy of the system. So where does it come from? Well, it's released from rest. This guy loses potential. He falls to here. So again, drawing the final situation is going to help you. So this one falls, and that's going to bring this one up. And so the change in energy total is 0. And so the change in kinetic plus the change in potential equals 0. They want you to solve for the change in kinetic. And so it's the change in potential and then change the sign. So there's a change in potential here. Is that positive or is that negative if it goes down? There's a change in potential here. The height would be different than what it was over here. Should be able to figure that out. And does this one go up or down? Is the change in potential positive or negative? Put those changes in here, and then watch it. You got a minus sign here, and that'll be the change in kinetic, which should be positive. There are other ways of doing this, and so if you come up with your own way, that's fine. Take a look at my long movie on the Atwood energy approach on my energy website. And number 8, this one you kind of have to picture it. The first part here, the pendulum's released from rest, and it slides down, or it swings down, and down here at the bottom, how fast is it going? And so you can get the change in height, and the potential equals kinetic. That one should be easy. The next part people have trouble with because you have to draw the final situation. Where is this pendulum going to go? It's not just going to stop here. Where will it end up? So you have to draw where it is at its highest point. Here's a hint. I'll show you this movie of something similar. If you remember, we saw Professor Feynman do this during his lecture. And so the pendulum's released. There's a little peg here. It hits. Oh, that's what it does. So where was the highest point? And so draw this guy at its highest point, and you can figure out where it is and then use conservation of energy to get the answer. Good luck.